Build a simple Flappy Bird style game and host it on port 3000.
Done. Flappy Bird is live at H Raspberry Pi controls. Click or space to flap. Give it a go.
Hi everyone, welcome back to the channel. What you can see today is probably the thinnest AI chatbot you can build with a Raspberry Pi. If you have watched my earlier videos, you have seen the Pi 5 built with the accelerator, the fan screaming at full speed. That thing is a powerhouse. It is also the size of a small brick. Is it portable? Not really. I have always been fascinated by the idea of a truly portable voice AI, something you can carry around, talk to on the go. So today we are going the other direction. Thin, light, quiet. The kind of thing you can clip to a bag or just toss in your pocket without thinking about it. On the software side, I will set up with OpenAI for speech recognition and text-to-speech, and OpenClaw as the brain. If you want to build this yourself, all the links and guides are in the description. Just copy and paste the commands, and you should be good to go. Now let's build it. The hardware is still the same 3 boards we used in the previous builds. The Raspberry Pi 02W, the Whisplay head, and the PiSugar 3 battery. But the case is completely redesigned to give it a flat profile. I put the battery on the side instead of underneath. So everything sits in a single thin slab. First, we need to mount the Pi 0 and the PiSugar PCB boards on the inner fan, using 4 M2.5 metal screws. The inner fan will keep the battery on the left side, the Pi and the heads on the right. Then plug in the Whisplay head on the top of the Pi 0. Now we have the core components assembled. Second, put the core into the shell and clip these to the sides. Secure the side leads with M2 screws. Third, attach 2 orange covers on the left and the top right. The left cover is just for aesthetics. The top right opening is for the camera. We won't be using it in this build, but it is there if you want to experiment with vision later on. Okay, let's go through the full software setup from scratch. Step 1. Flash the OS. Grab the Raspberry Pi imager, pick Raspberry Pi OS 64-bit, and flash it to your SD card. In the imager settings, pick a username and password. Set your Wi-Fi credentials. Enable SSH. Write it. Pop the card in and power out. Step 2. SSH in. If you can't find the Pi's IP, use a network scanner. Give the Pi a minute to boot. Then SSH in from your computer. If everything runs right, you are looking at the terminal prompt. Step 3. Install the Whisplay drivers. This sets up the audio codec, the SPI display, and the GPIO for the button and LED. Copy the install commands and run them. The Pi will reboot once. After it comes back, run the test script to light up the screen. Make sure the display driver and the button are working.
Transform your Pi into a portable interactive device with the PiSugar Whisplay head. Transform your Pi into a portable interactive device with the PiSugar Whisplay head.
Then test the speaker and microphone. Record a short clip, play it back. Hi, what's your name?
Hi, what's your name?
If you hear yourself, the audio hardware is good. Step 4. PiSugar server and Wi-Fi config. Install PiSugar server. This gives you the battery monitoring and the real-time clock. Then install Sugar Wi-Fi config, so you can change the Wi-Fi networks with Bluetooth low energy, which is handy if you move the Pi around. Both are one-line installs from PiSugar repositories. After installing, you can check the battery level from the web dashboard or the command line. And you can discover your Pi in PiSugar app on your phone to configure Wi-Fi without needing a display or keyboard. Step 5. Install the Whisplay AI Chatbot. Clone the Chatbot repository. Run the install script and let it pull in all the Node.js and Python dependencies. This takes a few minutes on the zero. Grab a coffee. Once it finishes, copy the env template to create your own .env file. We will fill in the details in a moment. Copy and run the script to build the project. Step 6. Install OpenClaw on your main machine, plus the Whisplay IM plugin. For this video, I'm not installing OpenClaw on Pi 0 itself. This time, I will run OpenClaw on the Pi 400, which is still a Raspberry Pi but has a much beefier CPU and more RAM. Install OpenClaw following the quick start guide. Copy the commands and run them. After installation, run OpenClaw configure to set up the agent model. Pick whichever providers you like and set the API key. In order to open the web UI of OpenClaw running on Pi 400, we need to initiate a port forwarding from Pi 400 to the local machine, and do a quick test from the web UI to make sure the model responses. Then clone the Whisplay IM plugin. Install it with the link flag using the OpenClaw client and enable it. We will configure the channel details shortly. The important thing is OpenClaw is running on the host machine and the plugin is loaded. Step 7. Get your OpenAI API key. Head to the OpenAI platform website. Link in the description. Create an API key. We will use OpenAI for both speech-to-text and text-to-speech. So one API key covers the whole voice stack on the device. Add some credit and keep it ready for the chatbot config. Step 8. Configure the chatbot and test. Go to the chatbot folder, open your .env file. You are setting a few key things here. First, tell the chatbot to use OpenAI for ASI and TTS. Second, and this is the interesting part, set the LLM backend to Whisplay IM. That means the device won't connect it to the large language model directly. Instead, it hands off the conversation to OpenClaw through an IM bridge. Then paste in your OpenAI API key and bind the bridge host to any address, which means it listens on all network interface. Also pick a token for the bridge, any secret string you like. You will use the same token on OpenClaw side of your main machine later. Save the file, restart the chatbot. Then we need to configure OpenClaw plugin to connect to the chatbot. Navigate to the OpenClaw channel page. Added a new account to the channel, and set the Whisplay IM channel to use the same token you set in the chatbot env. The IP address should point to the Pi's local IP. Save the config, and you should see the chatbot connect in OpenClaw logs. The channel will show as active. Alright, everything's set up. Let's have a real conversation.
How is current weather in Los Angeles?
Sunny and mild in LA right now, 17 South. Feels like 17 Celsius. Light northeast wind, 56% humidity. Basically perfect weather if you ask me.
Create a shopping list for me. Add some milk. I will add more items later.
Done. Created shopping list.md with milk on it. Let me know when you want to add more items.
Add some bananas to the shopping list.
Add it.
How many items are there in my shopping list?
Two items, milk and bananas.
Build a simple Flappy Bird style game and host it on port 3000.
This task is a bit more complex. After a few minutes, it tells me it was done.
Done. Flappy Bird is live at Raspberry Pi. Controls. Click or space to flap. Give it a go.
At that point, you just need to open the Pi 400's IP address in your browser on port 3000 to start the game. Aside from being a bit difficult, the game is actually very well completed. So far, the chatbot and the OpenClaw are on the same local network. But what if you take the chatbot outside? Now the handheld device and your OpenClaw host are no longer on the same network. That's where Tailscale comes in. Install Tailscale on both machines, the Chatbot Pi and the machine running OpenClaw. Then log both of them into the same Tailscale account. Once that's done, they can reach each other even when they are on a completely different network. You will see a VPN icon on the top of the display. That's a nice visual check that the terminal is active. Then go to the OpenClaw channel config, find the Whisplay IM channel, and change the IP address to the chatbot's Tailscale IP. That's really the key change. Since Tailscale works over the internet, the chatbot doesn't have to be near your OpenClaw host. You could literally carry it in your pocket, walk into a different building, and it still works. So today we didn't build the most powerful version, we built one that actually feels like a portable product. A flat case, PiSugar 3, Whisplay, Pi02W. OpenAI handling the voice pipeline. OpenClaw handling the thinking on the bigger machine over Tailscale. It goes from cute talking gadget to actual portable voice terminal pretty fast. If this is useful, subscribe, hit the bell. You already know the drill. Links to everything are in the description. And we have got a Discord now, so come hang out. Thanks for watching and see you in the next video.